Oh, welcome to Sunday Science on this fine Tuesday evening, everybody. Glad you could join us again. We're keeping on with our climate science series this week, and we'll be up through Earth Day, so hope you're enjoying it. I know that we all sure are. One of the things, real quick, I don't have a lot myself, but our esteemed panel does have a lot of information to share today, so real quick, since we've been talking about some of the core sampling techniques and science behind that, I just wanted to share this quick video from SO Mass. It's in regards to paleooceanography and paleoclimatology, and the core sampler that they're using. This video's a little test shot of the rig in action. I believe it was in the Bahamas, if I remember from the description right. But real cool looking little contraption, and helps show how even just through even some basic seafloor core sampling, we can gain a tremendous amount of knowledge into the past and how our climate has shifted throughout the years. And it's just a lot of fun. So if you want to reel that up, Cy,
very good.
I think it'd be pretty cool.
Alrighty, and here that comes. This is a cool thing.
I can't see anything.
I can see it on the PC, but not on my phone.
Hold on, let me do a screen sharing for you guys then, so you can see what's what. I'll just have to remember to turn it off in a bit. This thing.
It is one of the coolest looking contraptions for core sampling I think I've seen.
Oh, indeed.
It is pretty cool looking.
Can you explain how it works?
What? Oh, I couldn't explain how that works. Is it? Well, okay, so it's in the water now.
I mean, now that I've actually seen the thing, I could back engineer it from looking at it, and then tell you how the one that I back engineered functions.
Yeah, and then the copy of the patent letters start showing up from lawyers.
Well, you know, it does happen sometimes.
Okay, I didn't know the camera was going with it. I thought we were just going to see it drop into the water, and that was it.
Oh no, we actually get to see it doing its job.
Oh my.
It's almost like a Disney ride at Epcot. It's kind of cool.
Oh, this is cooler.
Yeah. It's like Mission to Mars, except Mission to Ice Core. If our seats rumbled, that would go really well with that. So these individual cylinders, are those the... I can only assume that those are the things that are extracting the samples?
Those are the actual sample containment vessels, if you will.
Okay. That makes sense.
This
So
must be
6 at a time? Is it 6 at a time that they take them?
Yeah.
Oh wait, we're up to something. We're up to something.
Is this just a surface apparatus, like, and then it just goes down to those tubes and doesn't go any deeper?
From what I understood, it still is just a prototype, I believe, that's in this video. So it is only going to be taking a shallow surface sample, but the rig could definitely be redesigned a little bit from what I'm noticing, and could easily take a 3-foot core shot.
So
No problem.
So this is prototype model then. Okay.
I
So
believe
this is a spider prototype, right?
Is this
Yeah.
like 6 actuators that are on each individual arm that extends out?
Yeah, so each sampler has an actuator, and it looks like the sample tubes themselves are vertically actuated along with the little
Yeah.
armature going out and scooping underneath them.
Do you think there's like a vacuum apparatus on the inside of that, possibly to help withdraw the sample up into the tubes?
There could be. It looked like the tops of the tubes were the cover flaps appeared they were all open when they first submerged, and then as the arms came pulling through, it did actually shut those, and you could easily have a some sort of a
Pressure change.
Well,
yeah, absolutely.
All right. Well, it appears we've captured a deep water sample. I'm guessing.
That would be of the ice. It looked like there was, actual, matter that was going up in it. So was it hitting like a submerged?
I don't know. I think it was just seafloor that it was hitting.
Oh, okay. Seafloor. All right.
There are, obviously with like what we were talking about with all of our fun with caves and everything else. Of course, most of the seafloor is it's former organic matter and present organic matter. So you still have a lot of oxygen level measurements that can be taken.
Okay, now we're
Carbon
getting
dioxide measurements that can be taken.
Now we're getting a better view of the capture. Did you see Tesla's?
Yeah,
comment?
that was great.
the claw machine reference was great.
So this is just a really hyped up claw machine, right?
Indeed. All right.
I suppose.
Yeah. How neat.
But
Isn't that
kind of a
cool?
neat thing just to take a look at, and with all the different, obviously we've talked about stalactite sampling and doing cross-sectional cuts there, being able to go through ring growth on trees and being able to see warming and cooling trends, especially with our nice old trees such as bristlecones and even giant Douglas fir and redwood. And obviously the sea gives us a major opportunity for study and research in this realm as well, with coral sampling, seafloor sampling, and the ocean itself sampling.
I think Havoc just joined. He wants to know what the thing is. That's a highly technological seafloor grabber.
Yes.
I'm not
I
sure.
just told him it was a Borg spider.
It's a. All right. That's
It's a fraternity party. It's the floor grabber. 6 frat brothers hit the ground.
Oh man.
I couldn't help myself. I'm sorry. I used
It
to
is
be
No worries.
fraternity parties were just the worst.
Being a saint myself, I have no idea what you folk are talking about. Alrighty. And a lot of the instruments of this sort, that I keep getting the feeling that there's a lot more we could be doing, because I don't want to use the popular phrase, "this isn't rocket science," but it isn't. This is standard technology that I mean, this is a machinist plaything, is what this is.
It kind of is. What I would be curious to find out is if they have any portable type of instrumentation that would go along with that. I know there's a lot of technological advances involving mass spectrometry.
Oh yes,
where
yes.
You can take a sample, run it through like gas chromatography, take a little bit, how it fractionates into different parts. Then you can kind of determine what isotope you have of a particular compound that you're looking for, or like an isotope, like whether it's carbon or if you have a different type of, because organic molecules, they can form different shapes, and so how they break apart gives you an idea of what type of shape that they're in regards to the mass spec. So you could have a portable mass spec. It'd be interesting to see if there are any proteins in there, what kind of proteins are there. if they manage to get any kind of organic matter, that might be fun. You could run it through a MALDI, but MALDIs tend to be pretty clunky. I don't know that they'd have a portable one, but I'd be curious to see what kind of portable instruments they have.
Indeed.
Absolutely.
And
So-
yeah, but for this device specifically, I mean, of course, I ran around the maypole 50 times before saying it, but the in this specific device, it's got to have a better name than the seafloor grabber, but it's
Don't say it.
is that I keep thinking there's so much room for involvement from people in so many different fields. Like I said, you know, the machinist's garage construction. One can construct something to do the basic grabbing of seafloor, ice cores, rock drilling. There's much room for everybody in these sciencey endeavors. Anyway,
Absolutely.
Yeah. So you could also consider analytical chemistry, trying to figure out what's in these particular samples, and then developing the portable instrumentation associated with that in order to determine what's in the samples. And then you got the whole aspect of biology. What about microorganisms? You know?
Absolutely.
And maybe they could maybe there's a various types of microscopy. I don't know of any like portable electron microscopy. I think that would be kind of hard. I don't know. You might could get it on the ship, but maybe not attached directly to a seafloor grabber.
Andy, I have a quick question about this, if you even know. Are the samples intact like they would be in a rock core, or are they mixed? They're just grab samples, right?
This one looks like just a grab sample, so I'm assuming it would be mixed.
Okay.
If I'm guessing that the idea behind the technology, at least this, if I was trying to develop a piece of equipment that served this particular function, testing just the basic mechanism that's going to ensure that you're going to, get a cover underneath your sample, and that all of that portion of the machine is actually functional, I would absolutely run a testing phase at this point before adding any sort of a core drill apparatus to it. But you could very easily add a core drill to the sampler tube and still have the little capture feet spider out, and then actually take more of a solid core sample with, layering the way that it's supposed to be so you can properly date and all of that fun jazz.
Sweet. I would love to see that.
So Havoc was mistaken. This is not a taxpayer-financed 8-man hookah, as Bo reminds us. Okay. All right.
Well, you got 6 tubes. I mean, would that be a 12-man hookah if you had 2 per tube?
Could very
There's
well
8
be.
tubes, aren't there?
1, 2,
I thought there were.
Are there 2
1,
in
2,
the
3,
back?
4, 5, 6. I thought there were 6.
Oh, there might be 8 actually. I thought there was 6 as well, but there might actually be 8.
Look
I
at the
was
support arms in
wrong.
the back.
I'm looking.
Support arms in the back. It appears to be an 8-tube hookah.
It definitely makes more sense that it would be called the spider apparatus as opposed to the crab apparatus.
Indeed.
See,
wait.
I missed that.
Oh wait,
altogether.
crabs are right in there with the arachnids within there.
Well, yeah, it's kind of,
I don't know. Do crabs have 6 or 8? I don't know.
6. They have 6, but they have arms.
Yeah.
That's
Right.
why everyone thinks daddy long legs are these. Oh, they're spiders. Yeah, no, they're land crabs.
Excellent.
Yeah.
Ever seen a daddy long legs clean itself? It's so cute.
I have not. You know what's
Yeah.
sad with the daddy long legs? Have you seen them late in the season? Because those highly evolved legs of theirs wear out over the course of the summer.
Oh.
And late in the season, I've seen a 2-legged daddy long leg still trying to go about its spidery business, and it was the saddest thing ever.
Oh man, have you seen them early in the year when they're in giant balls?
Oh,
Wow,
they're
giant crab balls of. Woof.
yeah.
Oh,
As for the whole arachnid thing, let's not go too far into the genetics of that, or we're going to put people off of lobsters.
One of my favorite things though when I was a high school teacher is students, and sometimes I would just yeah, I would just catch arachnids or insects in regards, not like pollinators or anything like that. But I would catch like really big spiders, and then I would euthanize them in alcohol. And then I would put them under a stereo microscope or a dissection type of microscope and let my students look at the intricate details of spiders. And one of my favorite things I did, I don't know if I've told you guys this story. One point in time, at the end of a talk or a lecture I was giving, I asked the kids, I'm like, who wants to look at spider eyeballs? And they're like, I do. And this is high school. And so one kid just raised their hand, and I was like, yeah, you have a question. And he was so serious. He said, how did you get spider eyeballs? I looked at him. I said, I left them on the spider. He thought I had gotten little tiny knife and like removed spider eyeballs. That's a completely separate thing.
Oh, man.
Oh, blast. That was so funny. I could pull the wool over their eyes. I played so many pranks on my students. It was fantastic.
Oh, that's awesome.
Once I could draw them in with a story, I could just completely it was Halloween was the best time of year for me in my classroom.
I would imagine.
Very cool. Oh, so with respects to the sampling, I had mentioned one of the things that is also measured aside from carbon dioxide, which we have talked about at length for a little while, is oxygen content. And that actually also stems from last week as well, with sitting down and doing slice sampling of stalactites, stalagmites, soda straws, bacon strips, all that fun underground awesomeness. And I'm pretty sure that Stephen has, in his field in geology, has some pretty cool stuff to talk about there. So why don't we pass things over to you, Stephen?
What? Who? Oh, yeah, me. Okay. No, seriously, I was listening. I just do a quick intro for the video that's going to get played here for a minute, because I know these rocks very well, because I visit them very often. But I just want to say that when we think of an ice age, we usually think of the modern Quaternary one. But these rocks actually preserve the oldest ice ages on Earth within the Huronian supergroup, which dates back to about 2.4 billion years. So I know you got it queued up, Si?
I do, in fact. Is everyone able to
watch it? Then I'll babble about it again.
All right, very good. I have can our esteemed panelists see the video screen? I have shared that for you. Andy, you got it?
Yes, I see it.
All righty then. Andy, your voice has changed. Okay, here we go.
Yeah, it happens when I forget to unmute myself.
When most people think about the planet, they think of it as it is. But when you study geology, you realize that the early Earth was not at all like it is at the present time. What gets geologists up in the morning is the possibility of determining how the Earth got to be as it is now. The appearance of oxygen in the atmosphere is extremely pivotal in terms of how the planet developed, in particular in relation to life. Once oxygen built up to the point that there was an ozone layer, then life could come out of the sea and come onto land, because it was protected by the shield from ultraviolet rays from the sun, which are deadly, which can destroy the body of the organism. Oxygen is one of the things that renders our planet pretty unique in the solar system and possibly in the universe.
I've often wished that I had a time machine to go back and collect an ancient bit of atmosphere, but we can't. All we can do is collect rocks that were formed under that atmosphere. So we go into ancient mountain ranges and we collect rocks and we tease them apart to try to understand processes that tell us something about that ancient atmosphere.
The Huronian supergroup is a thick accumulation of mainly sedimentary rock. At its thickest point, it is about 6 to 7 miles. It's located at the south edge of the Canadian Shield. By radiometric dating, we know it's between about 2.47 billion years and about 2.2 billion years. The Huronian group is particularly exciting and interesting because, by chance, these rocks were laid down at a period when the atmosphere underwent a transition from containing, we think, no free oxygen to containing at least some free oxygen. In order to investigate the atmosphere, we look at minerals in the rocks that react to the presence of oxygen.
While we were in the field, we looked at various levels of the Huronian stratigraphy. What you got here is sandier layers and then muddier layers here. The mud is almost purple in color, indicating a high iron content. But even the sands are also oxidized. They have this pinkish or reddish color due to the hematite.
So we think it's very shallow marine, very shallow amount of water above the sediment when it was laid down, therefore a very close contact with the atmosphere. And the atmosphere at this time may have contained at least some oxygen, and so we get this red coloration. That red color is a very good clue because it tells us that there was this reaction with oxygen. So it's a very simple kind of test, but it does give us at least a first order idea as to whether there was free oxygen or whether there wasn't.
This will be sample KY03-5. The rocks that we collected from various levels in the Huronian stratigraphy would bring back to the laboratory. We'll chip them with hammers, we'll crush them in grinders, and eventually the powders will extract with various chemicals to pull out sulfur, because it's sulfur that's telling us something, we believe, about the ancient atmosphere. Most of the sulfur in the atmosphere comes from volcanic explosions, and that sends a gas called sulfur dioxide high into the stratosphere. In the presence of UV radiation, sulfur dioxide will interact with ozone to form a certain compound of sulfur that gives us a signature that we can read in the rocks. However, in the early Earth, because there was no oxygen, there was no ozone, and without the ozone, there's no reaction and there's no signature in the rocks. And it's those ancient rocks that we're now bringing back to the laboratory to study that ancient atmosphere.
To better understand what the sulfur signature meant, we went out and decided to analyze a variety of samples from Australia, Africa, Greenland, North America, South America, and Asia. And the conclusions are the change from a large signature to a much smaller signature at about 2.5, 2.45 billion years ago is a result of a large change in atmospheric oxygen content from levels 100,000 times less than present to levels within about 100 times of present levels.
The most exciting thing to me about this research is that it quantifies amounts of oxygen in the atmosphere. Before, we just had this qualitative sense of, well, it was low here, it must have risen here. But the sulfur signatures that we're seeing allow us to actually get at numbers. The study of the ancient atmosphere does tell us something about the evolution of life on this planet. We have an intense desire to know where we came from. And that knowledge drives us to understand the earliest biology, the earliest atmosphere, what is the origin of life. And those are the driving forces that send us into the field to study these truly ancient rocks.
Oh, yeah, that's basically it. I just want to say before I start talking about it that it's pretty sad when you see them walking around these outcrops and you know you've been there and you can pick out exactly where they are. But this time, that period that they're talking about at the beginning of the Paleoproterozoic is very significant for two reasons mainly. Actually, three. But one involves plate tectonics, and that's not what we're doing here. But it's the most drastic climate change event in Earth's entire history, where we started to get, like they said, free oxygen in the atmosphere. And we know that by red beds in the Huronian supergroup. At the base of what we call the cobalt group, which is within the Huronian, we start to see red in the sedimentary rocks. And before that, you don't, even in the same group. And like he said at the beginning, it was just kind of a quantitative thing. Oh, there must have been free oxygen in the atmosphere because we've got rusting. So we really didn't. The sulfur thing's a good idea. I hope it pans out so we can get some actual numbers and actual percentages instead of, really low, lowish, that kind of stuff. But it's also the first time it's really weird. Is the second oxygen started, well, not the second, well, in geologic time, the second oxygen started to be pumped into the atmosphere, the ice starts to grow. And we got glacial cycles. The Huronian, I believe there's 3 ice ages, each with different amounts of cycles. The Gauganda, the last one, the Gauganda Formation is the thickest, and that shows at least 3 glacial periods within that ice age. PBS Eons actually did special on this, where they said the glaciation lasted for 300 million years, which isn't true, because these things are capped by braided stream sands and stuff like that. They also, around this time too, is also we start to see in the geologic record, we start to see carbonate rocks really come into their thing. They start to become really common. They weren't before this. And we still have banded iron formations during this time, which we don't have on Earth anymore. Yeah, I think that's it. I think I'm done babbling.
That's pretty awesome. It'll be exciting to see where all this research leads with the. Yeah, that's just cool.
Yeah, it was called the GOE, or Great Oxygenation Event, and it took me years to pronounce the word oxygenation.
Oxygenation. I still get words wrong too. I like telomerase. I say telomerase, but it's telomerase. I don't know.
You mean
I say words wrong?
I've been saying telomeres all this time, and I'm just wrong. Thanks, or I'm leaving.
Oh, don't worry. I was thinking
either.
Public chat there for a minute, and I'm pretty sure I'm the only person that saw the whole bit about Thorin. Was immediately thinking about the Asgardians from, Stargate.
Stargate.
I was the only one thinking Stargate, Asgard, and that Thor, and of course that Thor is the god of science.
Indeed.
Okay, I might be a nerd.
It escalated from hammers and science, and I'm like, please let a geologist have a hammer named Mjolnir. I don't know if that's the way you say it. Mjolnir. See, I want to be like, but you can say it just meow meow.
Yeah, in the second movie, she called it meow meow or mew mew, right? Something like that.
Yeah. The hammer that's the kitty. Meow meow. That sounds like it'd be a way more powerful hammer if they just named it like meow meow. I was like, this is the meow meow hammer. You're like, wow, it's probably super ultra cool or something. Just smack down. So we were talking about Thor having more data integrity than Loki. So it went from hammers to Meow Meow to Thor being a scientist and Loki lacking data integrity. And they were like, what about peer review? And they're like, the Avengers, like, but Captain doesn't understand what words mean. So it's like, but Tony and Bruce, that's okay. So I think we resolved that.
All righty.
So,
awesome.
So apologies for the chat not being on track.
No. I should have figured this day and age everyone would be talking about the Avengers as opposed to Stargate. I mean, Stargate's been off the air for a little while, and
yeah, but Stargate was awesome.
Oh yeah, and
what's this off track?
What's this off track? There's no track. We're trackless.
The train's just rolling down the hill sideways. Yeah.
What? Okay, no, this is Back to the Future where we're going. There are no roads, right?
Yes.
There are no roads like that.
Well, what else would be the purpose of scientific research?
It's the only thing that we're bound by is the scientific method because it helps. It's effective. So as long as you're following the scientific method, it's so effective at problem solving. You can use it across the board. So as long as you're using that, that's the only thing you're really bound to in regards to science is just the method. Beyond that, hey, it's so simplistic.
Indeed.
So, do you guys, random here, do you guys say trilobite or trilobite?
Trilobite.
I say trilobite.
I say trilobite.
Somebody asked about my games. I'll show my games very quickly. I actually have also an original Commodore 64 and an original Atari, and I have like 40 Atari games. I need to rewire my Atari so I can hook it up to my TV and see if I can play it. So yeah, I do have old NES games in my background. I got Star Tropics. I got Spy Hunter.
Ooh, Spy Hunter.
I nearly burned down my house playing that game. That's another story.
Have we all set fires to our places of residence?
That's one of the rules to get on Sunday Science. You have to start at least one conflagration.
One fire. So yeah, so Spy Hunter, before the youngins of the current day and age where you could save at like a boss level, Spy Hunter, there was no saving. If you died, you died. I had finally gotten to the part of the boat. Okay, so Spy Hunter is like it's like a car game. You're just in a car the whole time, and then a motorcycle and a boat and stuff. And so I was melting some grease in the kitchen because I was going to cook some French fries because French fries and video games, right? And so I was just a little kid. I'm like, but I knew how to cook. I've been able to cook for a while. And so I was like melting that down. I was cooking me some French fries. That's what I was going to do. So before I got the fries in, guess what went boom right in the kitchen as soon as I got to the boat level? Freaking grease fire. So that wasn't fun. But my mom got like new furniture. She got like the kitchen repainted, got new linoleum. She's like, next time you start a fire, do it in the bedroom. Because I need new furniture there next. So then we got
that was nice of her.
We got Spider-Man, and then I've got Load Runner right there. Yeah.
Oh my.
So those are my games. Only because somebody asked.
Copernicus thinker.
Oh, thank you,
Copernicus.
Another tribute to Mel. That would be 1,000 subs, Mel, by the way. Just saying.
Oh, thank you. 1,000 subs. See, but I haven't had 4,000 hours of viewing yet, so I'm like at 800.
I told you before. I told you before the show. You will in short order. Trust me on this one. So
I'm almost to 1,000. I'm almost there. I think I'm at 920 or something now.
Mel, you've got a functional Commodore 64.
I do, and I have a tape drive.
You know what? Oh, you know what I used to?
The 5.5-inch floppy.
Every time I think about it,
I don't. I have a tape drive.
Cassette
tape.
I tear up because in my younger days, the mom came home with a computer one time and said, "Here, boy, you're going to need to know about this." And as it turns out, she was right. And it was are you familiar with the SX64?
I don't think I don't have that. I don't have the S. I have it right over there. You want me to go get it for you?
No, don't trouble. This is the SX64 was Commodore 64, but it was the portable model. It was about as big as a suitcase. It had a built-in little monitor. It was about I don't know.
Oh, I didn't have that. I just had the legit keyboard.
Built-in.
And I
5 1/4, and the front snapped off was a keyboard. It's what in the old days one would call a luggable. It was only a laptop if you were utilizing maybe 2 people's laps at a time. I wish I still had the thing, but
the 80s.
See, I have an original Atari right over there, along with a Commodore 64. My Atari, I need to recircuit a bit to see if I can get it. It would work, but the thing is, it has the 2 prongs on the back that you would attach to like the RF modulator of your TV. I don't have that. I have HD everything. I'm like, that doesn't quite fit so well on that. So I would have to find a way to modify that to where it can fit into an HD. Then I could play E.T. What a terrible game.
You know what? I got a Raspberry Pi credit card computer right here. I'd be willing to I suspect we could make that into a converter immediately because it's got an HDMI out, and you'd be gaming like. All right, I ran out of words. You get the idea.
Man.
Anyway,
that'd be great. I have like the original paddles and everything. I have Pac-Man. I have E.T. I have Indiana Jones. I have Indiana Jones made me so mad. E.T. made me angrier because as soon as you send him home, they just brought him back and dropped him off. That was how the game went. You avoid the FBI agents, and he finally gets up into the spacecraft and goes away. And since there's no actual ending, it's just an endless loop. They just bring him back and drop him off.
Wow.
It's terrible.
How sad. That's very sad.
Look at David. David says gaming like it's 1988.
War Games is going to be a TV show. We have gone way off topic. I'm very sorry, guys.
Yeah, and
it happens every now and then.
So who else here named their 80s computer Whopper?
Oh my! All right, I was in the 80s. I was lucky because at the time I had a friend who gave me. I mean, the 64s were cool. The original Clive Sinclair machines were cool, but somebody actually gave me because they wanted it out of their garage. An old Xerox CP/M machine that used huge 8-inch discs, had a massive 64K of RAM to do all its thinking. Funny thing was, as long as you didn't go into the goofy graphics, 64K was more than enough. But that's another thing that went by the wayside. Anyway, alrighty.
Shall I talk about climate change?
Okay, and yeah, I actually in the chat I got a little nuts. I was almost, and that would probably be for a future show. I mentioned the whole, as humanity is we do a lot of work in chemistry, as you know, and there's enough. We do a lot of polluting the environment, and I did just offhandedly mention the DHMO problem. Yeah, we'll go into that maybe in a later show. Anyway,
okay.
back to you.
Johnny 5 is alive. Oh my god. Or no batteries required, right? That's another one.
Batteries not included.
Batteries not included.
Batteries not included. That's it.
Yeah, you guys are giving me flashbacks here, the 80s.
Oh man, I have to watch John Hughes films later. Oh goodness! So climate change—that's a thing. Mm-hmm. Let me see. So I was looking at weather patterns because I thought that's what we were going to talk a little bit about is weather patterns. And so some stuff that I've found, NOAA, NOAA, has teamed up a little bit with other academics, and I have some information in regards to that. Not only are we seeing, like extreme weather that's associated with global warming and climate change, there are different indicators that they have to kind of get an idea. And so people are like, well, it was just as hot this one time, or it was snowing, global warming is not real. It was snowing during the winter time, or things of that matter, it's not just what happened that one year. The idea with climate change is to look at the trends over a period of time and to see where it's going. And so some of the key things and the things that, for instance, the EPA and NOAA look at are like U.S. and global temperatures, high and low temperatures, precipitation, if there's heavy precipitation, tropical cyclone activity, river flooding, drought. And so these particular things in regards to weather are things that they measure and keep track with in order to kind of see what the trends are over time. Yeah, it still snows in the wintertime. Yeah, for some areas. And we're looking at different areas have more extreme type of weather. So NOAA actually paired up with Princeton, and this came out January 2017, and they're still kind of studying it. We know that we have mild days from time to time in certain areas and certain type of climates where you're like deciduous area. You're supposed to have hot summers, cold winters. The more up north you get, the more cold you're supposed to have. The more southern you get, the more hot you're supposed to have. Well, with this research, they were using climate models. They show a change in the estimated number of mild weather days for major cities in the U.S. So mild weather days mean days that aren't incredibly hot or extremely cold and, wintry, those types of things. Just, like regular type of mild temperatures, mild precipitation, that sort of thing. So in 2017, the current number of annual mild days by 2017 for Chicago was 77. And so with the current models, they're looking at annual mild days between 2081 to 2100 to be around 68 with the trend that's happening right now. So we see a little bit of a drop in mild days. Miami, we have a current number of mild days in Florida of around 97. That time frame, about 60, 70 years from now, is going to drop to 69. So we're losing almost 30 days of mild weather just in Miami. So it's going to get hotter more in the summer. It's going to get, when it does snow, it's going to be like pretty crazy. It doesn't snow so much in Florida, but if we're talking about like hurricanes and tropical type of cyclones where you're going to have stronger precipitation, you're going to see an increase in that. New York City, it goes from 83 mild days to 77, so it's dropping a bit. In Seattle, we see an increase from 88 annual mild days to 97. And so Seattle is expected to gain annual mild weather days, while the other three cities will lose these days, defined as having low humidity, little to no rain, and temperatures from 64 to 86 Fahrenheit, not Celsius. And so the tropics are going to lose milder days. They're going to have hotter days. Parts of the U.S., Canada, North Europe are going to gain milder days. So where we would see heavier precipitation, colder weather, you're going to see milder days in those regards. So that's kind of interesting. So even though we're talking about cyclones and tropical storms and heat, milder days are going to be affected too. We're going to have less of those in certain areas and more of those in others. So that's something to kind of keep in mind.
Colorado is definitely experiencing a wild influx of mild days. I think it snowed twice here in town this entire winter, and not once in our snowiest month of the year.
Ooh. Well, Andy, I hope it stays like that so when we're out there in July,
No snow in July, man.
Well, at the same rate, though, we did have a blizzard at the end of May last year, so it's, that's once in a 30-year occurrence. But yeah, we're pretty dry, and maybe about 50% of our average snowpack. It's pretty dangerous when all of our drinking water relies on snowpack, when all of our agricultural water depends on snowpack, when that starts to be depleted, we start getting in trouble.
Ooh, are we predicting droughts out there?
I know we're going to be on water restrictions, which I'm glad that recently we changed laws to allow me to I can actually gather rainwater finally for the first time in my life legally.
That was prohibited?
I can't believe they don't let any people do that in places. And Andy, stay away from our Great Lakes. You can't have any of that.
I will leave the Great Lakes alone, and at least I don't have to hide rainwater underground anymore. I'm glad about that one.
Isn't there a substantial algae problem with one of the Great Lakes because they cleaned it up so well, the algae actually overgrows? I can't remember.
Well, there's Lake Erie, also known as Lake Ew, but I don't think they ever actually cleaned it up. But it is known to have very big algae blooms because on average, it's only like 50 feet deep. It's very shallow. It's not like Lake Superior, like a real lake.
It's a fake lake. It's pretending to be a lake.
Lake Superior is my favorite. So, nothing.
Yeah, closest thing that I have to a lake is all artificial.
Oh.
All we have is reservoirs.
Yeah.
I mean, our rivers aren't even rivers. I mean, we're headwaters, so it's hard to even call any of the rivers while they're still in Colorado actually rivers. They pale in comparison to downstream.
It's pretty interesting. So if anybody is curious about what my sources are, I've gone to, NOAA.gov, NOAA. Also, another website you can check out in regards to looking at different of how they track weather and correlate it with climate change is EDF.org. The Environmental Defense Fund. So that's another website you can check out. They show what their work is, how they get the results, what the science behind the work is. And so they actually do measure the extreme weather, and they show how climate change is kind of linked to this, the extreme weather. But then there is also a lot of information on NOAA.gov. If you just type in NOAA weather climate change into a Google search bar, you'll be able to pull up all of the information they have there. And then they have it broken down on the different weather indicators that they have. So we're probably going to see more flooding. We're going to see a lot more rain, especially in areas where there's high evaporation rates. Out here, we tend to have flooding season in May. So it's almost like Mother Nature is negligent over the summer and just dries out all the crops. And then, one year we had corn mazes. The corn mazes were so short, they couldn't have been more than like 2.5 to 3 feet tall because the drought over the summer was so incredible that our corn mazes for the fall were just sad. This was a couple years ago. I thought, man, what's a haunted corn maze if it's like 3 feet tall and you see the guy coming? It's just like, I'm going to just hop over to the next side over here.
I guess that's when you have to make it a crawling zombie maze.
It's a crawl. But people would have to crawl too. That's what's so sad. You don't want corn mazes that are 2.5 to 3 feet tall. No, you don't want crops to be that small, period. No, not at all. But that's an indicator to kind of show. So, I mean, the more evaporation you have, the more likely you're going to have larger amounts of precipitation all at once in one period of time rather than over a period of time, just kind of spread out. So we'll have more precipitation, we'll have more flooding, that sort of thing.
One of the areas I think would be fun for us to take a look at is how melting permafrost is going to change things.
Oh, yes.
I think we should definitely look at that for a upcoming episode before Earth Day gets here.
Indeed.
Oh, goodness, yeah. We'll be introducing all kinds of new microbes. Won't that be fun?
Oh,
Yay!
yeah.
Oh, goody.
Yay! Bacteria we haven't been exposed to for an extremely long time. That's
Well, on the
Right.
good side, my cabin won't be buried up to 6 feet in snow in the winter. There's that.
We've got some nastiness in the way of bacteria in the deep ocean as well. Don't we see some unusual diseases popping up every time there's an unexpected swirl near a landmass? I suspect there's a lot of nastiness on the Earth just waiting for us.
Well,
you know, this just sounds like the beginning of a sci-fi film.
Indeed.
It's
I'm
like-
pretty sure the
wonder what-
sci-fi film's already been done. I believe it was called Blood Glacier.
I've
Don't
not
watch it.
seen
Just
that.
don't.
Sure, but it does make you wonder with, earthquakes large enough off of the south coast of Japan, what could be knocked up out of the Marianas Trench.
Oh.
What sort of sediment has been sitting down there for the last couple of thousand years that has been undisturbed?
Indeed. It
It's
doesn't
all of
even
a
have to be,
sudden brought to life.
and it doesn't even have to be something particularly nasty. It's just something that our immune system goes, "What the hell is that?" that's
Yeah,
all it's needed.
Yeah, it doesn't have to be anything horrifically dangerous. A new cold strain,
Well,
Or maybe people
23
break out in
UVass
hives. There's like some kind of weird allergen that's
23
associated with the
UVass said
protein
Godzilla.
signatures.
Oh.
Godzilla.
Godzilla.
Has the side chat gone wonky?
Yeah,
It's okay.
indeed. That's part of the fun.
No, I want a Mothra. I want to see Mothra come out.
Gamera.
Mothra come out and just
Who was
in
the-
Gamera. Yeah.
Who was the flying turtle with the rocket arms?
Gamera.
That was Gamera. That's right. That was when he went
Wasn't there
spinning.
a song in one of the Gamera Godzilla movies? There was a song where people were singing Gamera.
Now wait.
Or I'm remembering like an MST3K episode where they were like singing along with Gamera. I don't know.
Oh, yeah, they did watch that movie, but I don't remember that episode at all. I mean, they
Oh,
only did
Freighter
like
Chaos, you're
400
right.
of
The
them.
tree insects in the X-Files. I remember that one with cocooning people.
Oh, yeah, the X-Files. Boy, that's a great show.
That's a great. I don't know about the remake yet, or
I
the
haven't seen the remake.
reintroduction. I don't watch television, so
You know
I'm
what's
still
funny?
catching up on years old TV.
The remake, if you're a fan of the X-Files, the remake is actually quite refreshing because Mulder has just given up on all of the supernatural stuff, but Scully's haven't had enough experiences to where she even though she questions stuff, she's like, there's stuff here I can't explain. And so she's actually trying to get Mulder to come back around to I want to believe type of thing.
I think
And
Mulder
Mulder's
gave
like, I've
up
done
when-
it. I've had it. I've had it with all this. This is crap. Everything's debunked. I'm done.
Didn't Mulder give up when he broke his glass jar protecting his hand, or am I getting movies and shows confused here?
I don't know.
That was Zoolander, remember, when he was a hand model? He broke it.
But the new series, it's kind of fun because they're older now and a bit wiser. They're not all bright-eyed and bushy-tailed. And Mulder's like, I'm so done with this crap. And Scully's like, well, this might actually be
as you get
supernatural. Come on, guys, let's try again.
As you get older, that optimism, that wide-eyed kind of fades.
Exactly. And you kind of see that. And then Scully's sitting there trying to push Mulder back, like, well, Mulder, maybe this is an actual thing this time, Maybe this is a real lizard person,
Well,
It's cool.
I had
as
something to say
far as
about
sidetracking is, I do believe we still have a member of our esteemed panel that has some very interesting information that they would like to share. And before we start stretching the show out too long, we're normally an hour long, and
Indeed.
I'm pretty sure we're going to go beyond that very easily today, and it's worth it with this series. I absolutely think more than an hour when it comes to climate science is an absolute necessity, but I know Spy has some very awesome information that he would like to share that also incorporates some really fun astronomy. I don't mean to just cut anybody off, but I also we did have a little bit of a plan, so I'll do what I can to try and make us stick to a plan.
We have no plan.
Yeah, we
Fair
don't
enough,
have a plan.
Andy.
I'm just making this up as I go along.
Fair enough.
Y'all know the plan. I hang out with these smart people and let them talk. That's the plan. Anyway, well, thanks. You know what? Honestly, what I was really going to go into was ICESat 2. If you remember, quite a while ago, I was hanging out at there was a NASA social at Goddard that was all about that device and that satellite, and it's actually on its way to some testing at the moment. But honestly, that's about a half hour of stuff. That we might want to maybe we'll save the latest ICESat 2 updates for another one. But what I would like to bring up here is to start off, I had a thing on the Arctic sea ice. Latest update. Mel, this actually, you may have included this in that fabulous presentation you did a couple of weeks back.
Oh, okay.
On March 17th, for this year, the Arctic sea ice reached its annual maximum. I'm not sure why they picked that day. That this is the maximum. Like, if it expanded past that, it was just, we're not recording you. It was 5.59 million square miles, and this is it's the second lowest maximum on record. The lowest was only about 23,000 square miles. The next one down was only about 23,000 square miles less. So it wasn't a big difference. There's definitely a continuing trend that the annual maximums are diminishing with every as time progresses. Again, there will be anomalies where oh look, see, it's not at the minimum, it's not wrong. Anyway, let me just bring this up here, and this is a quick one, and here we go.
All right.
Excellent.
On March 17th, the Arctic region reached a milestone, the second lowest sea ice maximum extent since satellite measurements began. The 4 lowest maximum Arctic extents on record have been in the last 4 years, according to analysis from NASA and the National Snow and Ice Data Center. This year's maximum extent reached 5.59 million square miles. But what does that really mean? How and why do we track sea ice?
We've got a good record of extents since the late 1970s. So by now, the record of the Arctic ice is clearly one of a decreasing ice cover.
To answer some of my questions, I talked with Dr. Claire Parkinson, who has been studying sea ice from space for the past 4 decades.
I got a job at NASA's Goddard Space Flight Center in July of 1978, and I've been here ever since. And I've had the phenomenal opportunity of getting to start when the satellite data was still fairly new, and when at Goddard people were trying to figure out how to use the satellite data to reveal information about the Earth. After several years, when we started getting a longer record, then our attention got changed into, well, what kinds of trends are we seeing in sea ice? We've maintained this record of sea ice, and we recognize now that it's very important for climate change because sea ice is one of the variables in the Earth system that has been changing the most dramatically, especially in the Arctic.
But sea ice doesn't just react to warming global temperatures. It can actually accelerate the temperature increases.
Now, the less sea ice coverage feeds back into the warming, because if you've got less sea ice cover, that means less of the sun's radiation that comes down to the surface will get reflected back.
Sea ice fluctuates with the seasons, growing during the cold, dark winters until reaching an annual maximum extent in February or March in the Arctic, and then shrinking through the summer until reaching a minimum in September.
In the Arctic case, in late summer, it extends over about 5 million square kilometers. In late winter, it extends way further over about 15 million square kilometers, which is about 1.5 times the area of Canada.
So studying sea ice includes tracking how it changes seasonally. Rather than just looking at the annual summer minimum, scientists track how the ice changes throughout the year to get a fuller picture of change.
Every month of the year has decreases in the Arctic, and it doesn't mean every single year has less ice than the year before, but it means that overall the trend is downward.
Well, that's a cool video.
Yeah, I've actually seen that before. It's pretty good. Somebody was asking what kind of video it was, and for some reason I can't type because I'd seen it before. I know where it was from. Excellent.
Yeah, that's straight from that. And apparently our at least some of our fears with again, like Andy always says, we don't do the political thing here. We just talk about sciencey stuff and things. But we were all greatly concerned that all climate data was going to disappear and become inaccessible on the internet. NASA's climate.nasa.gov is still fully populated with all the information you can eat up. So fear not, data is still available, and at least some of our fears are groundless. But yeah, I did like that particular video. And again, it's the trends we have to look at, not, oh no, we were 23,000 square miles bigger this year. And it's not looking good, because she did mention the feedback loop where a small increase in temperatures means more ice melt. More ice melt means less ice to reflect heat back off into space, and it kind of makes a nice little loop. But what I was going to go into, we got like a half hour of stuff later that we'll save that for another show. We don't have a choice at this point. But you notice in this video, we're tracking sea ice, and even in the terms they used, they were talking about surface area, that kind of thing. Now, seeing the outlines and the changes in the outlines of how much ice we have is good, but another video here, they mentioned ICESat-2. Seeing outlines is just great, but there's more data we can get. So here's a quick one on what ICESat-2 is going to do for us. Now, it's a tremendous increase over previous satellites. This tells us the height of things to just tremendous precision, and the resolution is going to be much better with this one.
Awesome.
ICESat-2's got a laser it puts out at it's 532 nanometers. I guess I could have just said green, huh? All right, yeah, it's green. It's a green laser.
Yes.
And I was told,
what shade of green? Is it chartreuse? Is it lime?
It's more the
pastel green.
It's the 532 nanometer shade.
That's highly specific, and I appreciate that. Thank you.
Alrighty. And let us not forget the highly technical. This was from engineers on the project. The reason that this particular laser at that frequency of light was chosen is because that happened to be the frequency that the detectors that NASA had on hand were designed to detect. So that's why that frequency of laser was used. Anyway, point being, here's a quick video on ICESat-2, what it does, and how it's going to help and give us more information than just the outline of how much ice we got, what the maximum, minimum, and the change over time, how it can be helpful. And then we'll go into how it works in a future show, because it's really freaking interesting. All right.
Yeah, I'm pretty excited for that one.
Here is Thorsten Marcus and friends telling us all about that. Here we go. And those rockin' NASA tunes.
From satellite data, we have a very good handle of how our Earth looks like. We can see oceans, we can see the sea ice, we can see our forest. What is much, much harder to measure is how high things are on a global scale. Almost impossible.
ICESat-2 adds the third dimension, the elevation. Repeating measurements from ICESat-2 will allow us to measure changes in the ice sheets or in the ocean or in land.
Met him.
2 is designed to measure the changes that are going on in the cryosphere, in the polar regions.
All the change is at the edges. Those are the steeply sloping parts of the glacier that interact with the ocean, and that's where all the action is. That's where all the mass is being lost.
In order to estimate the mass changes, we need to know the height of things. The mission ICER-2 carries a single instrument. It's called ATLAS, the Advanced Topographic Laser Altimeter System.
ATLAS sends out small pulses of laser light 10,000 times a second. And by measuring precisely how long it takes that light to go from the spacecraft down to the Earth and back up to the spacecraft allows us to figure out what the height of the surface is beneath ICER-2.
We need to measure the time of flight of a single photon or a single laser pulse with a precision of a billionth of a second.
NASA engineers had to come up with entirely new ways of measuring time very precisely.
A billionth of a second translates to an elevation change precision of just a few centimeters. Climate change is amplified in the polar regions.
That's freaking impressive.
ICER-2 is designed to measure those areas and will help us to understand what's going on with our planet.
It's satellites with freaking lasers that shoot out of it. And to detect the ice and the heights of things. That's awesome.
Indeed it is. And I will, like I said, the rest of the stuff I have is how ICER-2 is going to do what it purports to do. And, oh, it will. But, yeah.
Now, I do have a question.
Yes?
In regards to this one. With being able to measure altitude as accurately as it is, does ICER-2 or any upcoming instrumentation that you're aware of, since you've been able to attend several of these NASA events at Goddard, I wish I was on the East Coast for that reason, is there anything they can do for measuring sea ice depth? That you're aware of?
No, that's not. You know, I've been focusing on this little fella for so long, I'm not entirely sure. I'd have to assume, and now I'm going to go looking. I love when you ask questions like this. Now I'm going to have to go looking. That's not what this fellow can do. This is just surface elevation of the surface. But I would be willing to bet that the answer to that is yes. And now, God damn it, I have to go find out what it is they have that does that. You know, I had no idea.
Swear word, side strike.
Oh no,
this is what happens. And Mel, I blame you, because this is what happens when we have a teacher on the show. Somebody decides it's okay to start assigning homework. You did teaching, so that must be why Andy decided it was cool to hand out homework. So.
Oh goodness. I do have Thor here, and Thor is a scientist, we've decided, so.
I see.
I want to see your TARDIS, Mel.
Right.
Anyway. Okay, hang on.
Oh, wait, let me get back. Let me stop sharing the video so we can see Mel here. Here we go. And
okay. I do have a TARDIS. So you want me to go get it? I don't know if it lights up anymore, but it's a cookie jar. And he used to have snacks in it in grad school. And so anytime somebody would come to my desk and I used to have like M&Ms in there, I could hear it because it would make the sound.
The whoosh, whoosh
yeah, it would make the brakes are on. So I do have I can go get it. I think it's in my kitchen. You want me to get my TARDIS? I don't know if it lights up.
Wait, what's Bo talking about? Bo, what is it you couldn't see? Don't tell me you couldn't see that video.
No, I could see it.
I could see it.
Is that?
I can see it.
I can see it on both my PC and my phone. So
is that?
Should play it.
Well, we'll just ask Bo. Bo, did you see the video? All right. And, oh, you know what? The other thing about the video, it's I mean, you heard how Thorsten was talking about the project and all that. You know, he sounded pretty excited and all that. You think, well, that's for video production. No, it isn't. He and actually everybody else I met there is actually excited about the science they are doing. The way he was speaking during that presentation, that's how he speaks. That's not acting. That's in real life. That's how he talks about his job and what he does. And everybody I met there is the same way. They get excited as hell when somebody actually asks them, "What's all this science about?" And they will tell you in great detail.
So they're all David Attenboroughs.
So now I know who to give my list of questions to, since you know them all personally.
Absolutely. I wouldn't quite say that. I mean, it's not like they would know me if they were standing on me. But yes, I know who they are. Absolutely. But I've before I go to these events, actually, I do ask, friends, anything you want asked, and I do try to ask those questions when I'm there. Except for the last one where they were laser ranging satellites. That I was just too in awe of that device to actually even speak.
Understandably so.
It was just like so much tech.
It was.
Oh my gosh! He was spazzing. He was like a kid on lots of sugar. Just I couldn't think.
Did you ask him if you could turn the laser on, like a kid asked the cop that if you could turn the sirens on?
Well, see, that was the interesting part. Normally they would wrap things up around 5-6 o'clock, so everybody could go the hell home. This one went into the night because they did turn the lasers on and did ranging of several satellites and took us through the whole thing. And I think their record was they ranged, was it the lunar one, the lunar orbiter? Lunar Reconnaissance Orbiter, or anyway, they got some kind of ridiculously long range ranging where they measured the distance to the satellite to like centimeters. And
nice.
I'll have to, you know what? I don't even remember. It was a while ago. It was either the Lunar Orbiter or Mars, and I think it was Mars that they actually hit. Anyway,
cool.
Further,
I will save the
awesome.
I will save the last half hour of how ISAT 2 is going to help us know what the hell's going on for another show. But it is.
I just see Skystrike now as a little kid doing this like on a road trip in the big rig honks for him. And just, oh my god, he honked for me! I just see the little kid doing that, and that's what I think of when I see Skystrike talking about lasers.
I could totally see it.
Okay, so
I wasn't meaning to give you homework, Skystrike. I was just thinking about it because if aside from being able to measure altitude with such precision, if you can measure density to determine the amount of sea ice that is slush versus solid ice, the thickness that the ice is, all of that information would be so relevant. When it comes to all of that course area. So it's not like I'm trying to give you homework. It's that you just gave me homework, and I was just trying to reciprocate.
Andy, if they're only using green, they can't get thickness with it, can they?
No.
Well, yeah, you would need something more along the lines of radar for thickness and density, but
indeed, and this is not just it's not just ice. Remember, this thing can be used on rainforest canopy and all sorts of things like that. And Andy, I didn't mean to sound critical because giving me that kind of homework, I think you might recall, that's the kind of homework I like doing. So
I'm all right. Go research.
All right, so shall it be. I will return.
For science.
I will return with the requested information. And all the events in question. Everybody watching, do hit NASA's site. You know, you don't even need the address. Just type in NASA Social into Google, and poof, top response you get will be the place. Look into them. Anything close to you. If you are active on social media, give it a shot. And you don't have to be, science nerd to learn something. It's the group is from people all over the social media spectrum. I would recommend you.
I need to get on one. I missed the last one. I feel like a jerk.
Oh, I missed it too. And I was the one, if you recall, I was the one saying, "Go sign up. Don't forget to sign up." And then I check on the site and find that registration had closed the previous day.
Yeah, I have a little ways to travel to get to one of those, unfortunately.
Yeah. David says, "Go with the blessing of Thor." Here's Thor with meow meow.
Nice.
Awesome.
He's here to science you.
Now we need Thor in the intro. We need Thor in the intro from now on.
You know what? I could really make a lot of nerds angry. It's like, so Boba Fett and Thor were walking down the street.
and Spock shows.
Surprise comes
I think
along.
I've seen that on Epic Rap Battle History.
Thor is riding the Enterprise, your argument is invalid.
I can't watch. I can't watch. We have defiled the Enterprise. I'm averting my eyes.
Oh my gosh.
All right.
On his way to fight Boba Fett. In Oz. I don't...
All right.
Oh, that's the JJ Enterprise. It doesn't count.
Okay. That's Oh, Andy, look at the time.
Oh, wow.
I had no idea. I blame you, interesting folks, for this. We've gone 20 minutes over.
It's not my fault.
No, it must be genetic.
No one's blaming you, Mel. No one's blaming anyone.
I just answered questions about video games, which had nothing to do with climate change.
No blame.
And then
no blame is being assigned here. You and Andy and Steve are just genetically predisposed to being interesting. That's the cause.
Oh, thanks, but I disagree with that.
Oh, you mean you had
to
work hard?
Interesting.
What he means, Steve's disagreeing with that. Don't take that the wrong way. He means that it's not genetic. He had to work hard to become interesting.
Oh yeah, that's it. Yeah.
I think you all are interesting. It's always fun talking to you.
No,
guys.
it is great to be here.
Agreed. It's been a blast having you guys on the show. It really has been. Thanks for joining us. It's it's been a lot of fun.
I always learn something from each of you. It is great. But anyway, you want to wrap it up, Andy, and we'll continue next week with the stuff and things.
Yeah, definitely.
Are we going to make it on Sunday? Are we going to actually do a science Sunday on a Sunday?
Next Sunday Science will actually be on Sunday. No doubt about that one, unless someone's in the hospital, and I'm pretty sure I was the last one in the hospital, so it won't be me. Not this time.
Don't put that juju on me.
Well, don't let your cat run away, hide under a juniper bush, and then stick your arm into a juniper bush unknowing that there's a baling wire wrapped around a frickin' garden stake in there and slice your hand open.
Gotta wonder what the history of that was. I mean,
yeah.
I have no idea why the thing was under there. I still don't to this day. I also don't know why my cat ran away for like 4 months.
Strangely enough,
and then suddenly came home out of nowhere. But hey, I got my cat back. That's all I care about.
Episode. It's an X-Files episode. That's what that is.
Frater has called shenanigans. All right. All right. Maybe we should wrap it up for the evening. I hear there's other interesting things going on the interwebs we wouldn't want to miss. I think Red's got something going on. And
cool.
Alrighty, I suppose it is about that time. So I suppose we'll see everybody, or at least most everybody, back here next actual Sunday for Sunday Science next week.
So you say.
I'm not planning on starting any fires or accidentally slicing my hand open. So
don't play Spy Hunter and start French fries. It's a bad idea.
Okay, important safety tip.
Yes.
All right. Well, thanks for joining us for another episode of Sunday Science Not on Sunday, everybody. It's always a blast to have everybody join us, and I hope you enjoyed as much as we did.
Indeed. Evening all.
Night, everyone.